Good morning, all. I welcome you for the lecture series in the course Manufacturing and Measurement Techniques. We have seen the introduction to welding in the previous lecture series where we had two welding process. One is fusion welding, other one is solid state welding. So in the solid state welding, it is very interesting that there is no fire or heat generated using fire is applied to join metals. One such kind is friction stir welding. So this is a solid state welding process where heat is generated by relative motions between two surfaces, right? So we have studied friction in our prerequisite course in the second and third semesters for various branches like CSE, IT and mechanical. We had a course engineering mechanics where this friction is dealt with. So the very requirement for walking and standing is friction. So the same phenomena is used here, but when you move a rotating object or tool with the surface, there exists a rotary motion between the surface uh, generated by the tool, which will causes friction. So this friction will cause melt the metal and form a solid joint. So this is also used in all the industries like aerospace, construction, automotive, everything. So what is the principle of this friction welding is heat is generated between the workpiece, raises their temperatures, softening the materials and preparing them for welding. So once the heated parts are pressed together under high force using lathe, the softened materials to forge and flow, creating a strong metallurgical bond. The final stage involves consolidation of weld where the material cools and solidifies, forming a seamless joint. So we have four types of friction welding. One is linear friction welding, other one is rotary friction welding, and friction stir welding, friction surfacing. So these are all the four important areas of research in the recent manufacturing process. So considering linear friction stir welding, it oscillates the parts linearly. When you go for rotary friction welding, rotates one part against the stationary part. So friction stir welding, we use a spinning tool to generate frictional heat and force the material together. In friction surfacing, we deposit a wear-resistant coating on a base material through the friction heating. So this friction surfacing is finds many applications in preparing the surface only of a component which requires high wear resistant. So these three areas, energy sectors, we could see this friction welding in the production of turbine blades, nozzles, and other power plant parts. In aerospace, fabrication of jet engine components and airframe structures, we use friction stir welding. And in automotive industries, we manufacture drive shafts, suspension components, and all the engine parts using this friction welding. So finding the advantages in this friction welding, we get high strength weld. The weld zone exhibit excellent mechanical properties, often exceeding the strength of base materials. That is very important when you go for welding. So we always compare the strength with the base material. And we have a minimal distortion. The localized heating and forging process minimizes warping and distortion of the workpiece. And here there is no filler material. This is an autogeneous process, eliminating the need for filler material or fluxes. environmental friendly process since there is no fumes or gas burning in between the world. So the process is clean, energy efficient, and does not produce any harmful emissions or byproducts. So these are the process parameters in the friction welding: rotational speed, forging force, and upset allowance. And we usually go for visual inspection, non-destructive testing, mechanical testing, metallurgical analysis. So this is the future trend, automation and robotics. We use this high precision robots be required, and hybrid process like combining laser welding with friction welding, that is the needed research of the hour. And we also integrate this process with the industry 4.0. So we explore certain more interesting topics on this in the next lecture series. Thank you all.